Alright, so now I'm going to cover another situation in which this method is useful. We want to find the angle measurements when this statement is 0. So let's see if we can do that. So I'm going to go ahead and substitute I'm going to substitute these functions for the function with t. Okay, and then we just have to, it's just a simple matter of combining these fractions. That negative gets distributed, so I know it's going to be a t squared, and then a minus 1, but I also have a plus 2t. So the numerator of that is going to end up being that. And also you can see the denominator here. I'm going to just multiply it out. And the reason I can do that is because without having to worry that there's going to be an issue that this is going to be undefined anywhere, this is going to be defined everywhere because of the t squared. So it doesn't matter if this is a negative value, a positive value, or 0, the denominator is always going to be positive. So there's nowhere that it's going to be undefined. So we're just looking at what values is the numerator 0. So we just have to do this real quick. So this is just going to be completing the square. I want this to be a positive one, so I have to add 2 to both sides. And then once that's a positive one, I can factor it into t plus 1 squared. So then I know that t plus 1 is going to be plus and minus the square root of 2, or t is equal to negative 1 plus and minus the square root of 2. Okay, so at this parameter t, t is equal to negative 1 plus and minus the square root of 2. If I plug those back into these equations, I will get the points along the circle that make this true. So let's go ahead and do that. I don't have a whole lot of space to work with, so I'll just erase this, and we have the t values that we were looking for. So let's say what's cosine of theta? Well, that's going to be 1 minus this squared, negative 1. Well, we have two cases, so I'll just do the first case first. Negative 1 plus the square root of 2 squared divided by 1 plus negative 1 plus the square root of 2 squared. Okay. I don't know if I have enough room to do this, but we'll just give it a try. So 1 minus, alright. So this gets kind of complicated algebraically. I'm just going to do it, hope I don't make any mistakes, and just get through it as quickly as possible. So it's going to be 1 minus 2 times the square root of 2 plus 2 divided by 1 plus, alright, this is the same thing, so 1 minus 2 times the square root of 2 plus 2. Alright, so that's just 1 minus, alright, so the negative gets distributed in, so that's negative 1 minus 2, so it's 1 minus 3, so actually we have negative 2, and then plus 2 times the square root of 2. Alright, is that correct? I think so. Alright, now similar here, we have 1 plus 2, so that's actually going to be a 4 there, minus the square root of, minus 2 times the square root of 2. Alright. So remember, this is the case that t is equal to negative 1 plus the square root of 2. Maybe I'll just write like a comma or something. Okay. Or like a semicolon. So just know that this is that case for cosine. Alright, so we can change this. That's -1 plus the square root of 2 divided by 2 minus the square root of 2. Alright, to get this into a form that's not so horrible to look at, that's what I'm doing. I mean, we could have left it in this form and said, well, that's the number, but that's not a familiar form at all. So in order to do that, we have these techniques of multiplying by sorry, I forget the term for what we're doing here, but this is 1, and we're multiplying by that, and we're doing it in the hopes that we can reduce the denominator. We can get any irrational numbers out of the denominator. That's what the goal is here. So that's going to be negative. So this term times that term is going to give me -1, and then I have 2 times the square root of 2 plus -1 times the square root of 2. So that's negative square root of 2. Alright, and plus 2. So the square root of 2 times square root of 2 is 2. Alright, so that's 4. And then I have negative square root of 2 times 2, and positive 2 times the square root of 2 will give me 0. And then I have negative square root of 2 times positive square root of 2 gives me -2. So it's going to be negative square root of 2 over 2. Alright, did I do this right? That is the big question. I think I did it wrong. Okay, so this isn't right, and I thought it wouldn't be. I thought it wasn't right. Now I have to go through and figure out where I made this mistake. Alright, the mistake is here. It's going to be 2 times the square root of 2 is positive, and -1 times the square root of 2 is negative. So this is a positive square root of 2. So that's positive. Okay. So if you caught that mistake, then good job. So I think this is right now for the cosine. So for t is equal to -1 plus the square root of 2, we know the cosine of theta is going to be equal to the square root of 2 divided by 2. Now that's a familiar value that we can work with. All right, now let's try for the sine of theta. So that's going to be 2, and remember our t value that we're working with is -1 plus the square root of 2. -1 plus the square root of 2 divided by 1 plus -1 plus the square root of 2 squared. Alright, so that's going to be -2 plus 2 times the square root of 2 in the numerator, and it's going to be 1, and we just have to square that. So that squared is going to be, it's going to be plus 1 minus 2 times the square root of 2 plus 2. Okay, 1 minus 2 times the square root of 2 plus 2, because, alright, and now that's -2 plus 2 times the square root of 2 divided by 4 minus 2 times the square root of 2. I can factor out a 2, and I get -1 plus the square root of 2 divided by 2 minus the square root of 2. Alright, so it's taken on, looks like a similar form to the last one. So now I need to do the same thing I did with the last problem to get rid of this denominator that looks like that. And so I need to multiply it by 2 plus the square root of 2 to the top and the bottom. So the denominator we can see is going to be 4 minus 2 again. So 4 minus 2, and then negative 2, negative 2, and then we have 2 times the square root of 2 minus 1 times the square root of 2, so I think that's a plus square root of 2 plus 2. Okay, so negative 2 plus 2 gives us the square root of 2 divided by 2. Good, that's exactly what we were looking for. Square root of 2 divided by 2. So that's the sine theta. Alright, so we know this value of t gives us square root of 2 divided by 2, and square root of 2 divided by 2 is the coordinates that we're looking for. And actually, those coordinates are going to be like right here. It corresponds to an angle measurement of pi divided by 4. Alright, so I'm not going to work through the next one, negative 1 minus the square root of 2, but if I did work through it, it looks pretty much just like the previous two, and it gives us the negative values for these. So it gives us the point over here, which is negative square root of 2 divided by 2, and negative square root of 2 divided by 2 is the coordinates, which gives us an angle measurement of pi plus pi divided by 4, or 5 pi divided by 4. But actually, if you're familiar with the unit circle, we know we could also say negative, actually, in this case, I guess we would want to say negative 3/4 pi. 3 pi divided by 4. Alright.